All right, students. Now, what will we be learning in this chapter to begin with, right? First thing is we'll be learning about something called force, correct? What are different types of forces that you know in nature? Can you guys shout out? Gravitational force. Tell me about something else. Good. Magnetic force. Yes. What else? Frictional force. Kinetic force. Normal reaction. What else? Okay. Yes, yes, good. So let me classify. All your answers are valid, okay? Now let me classify forces into three main categories. First category is contact forces. What is it? Contact forces. What do you mean by contact forces? For a body to experience the force, there must be contact. Can you give me an example for contact force? Yes, very good. Frictional force is a contact force. If there is no contact, there will be no friction. Clear? All right, very good. Any other contact force? One more contact force. Friction is perfect. Excellent answer. Any other answer? Somebody said it is among the answers that you have given. Is already there. Anybody? Normal reaction. Somebody said normal reaction. Am I right? Who said normal reaction? Yes. Normal reaction is a contact force. If there is no contact, there will be no normal reaction. Is that clear? So, dwelling a little deeper, frictional force is a contact force. Normal reaction is a contact force. Frictional force is in what direction? Which direction is frictional force going to act? To the surface, you tell me. Tangential. Frictional force will be tangential to the surface. We'll see all that, okay? I'm just setting up the base right now. What about normal reaction? Yes. Shout out. Perpendicular to the surface. Tangential to the surface is friction. Perpendicular to the surface is what? Normal reaction. Is that clear, guys? And net contact force will be a resultant of these two. You have learned about, in motion in a plane, you have learned about parallelogram law vectors, how to find resultant of two vectors. Using that, you can get the resultant of the two forces, friction and normal reaction. That will be the net contact force. Coming further, there can be forces which are non-contact in nature. You don't necessarily require contact for establishing a force. Can you give me an example? Already the answer is there in what you uttered. Magnetic force, exactly. The magnets don't need to touch each other to experience the force. Even at a distance, a magnet is able to attract another magnet. What force is that? Non-contact force. Can you tell me another example for non-contact force? Gravitational force, exactly. You don't have to touch the ground. You will see the impact when you touch the ground. But even wherever, at whatever height you are from the surface of Earth, let's say, relatively, right? Relatively. You're in the first floor, second floor, doesn't matter, right? Or you're in mid-air, correct? Let's say you're 5 meters up. Earth, should it touch you for you to experience the force? No. What is gravitational force? Non-contact force. The force between Earth and Sun, what is it? Gravitational force, non-contact force. Clear? Sun and Earth are not touching each other, yes or no? But they still experience the force, right? What else? Moving forward, one more non-contact force, tell me. Nuclear force of attraction, very good, very good. But there is you don't call it as nuclear force, you call it as something else. Electrostatic force, to be precise, okay? Electrostatic force, if you see, of course, nuclear force, kind of you can say subset. Electrostatic force, any positive charge or a negative charge, right? What is going to be there? Force of attraction between them. Any positive charge and another positive charge will have force of repulsion between them. They don't need to be touching each other. These are what forces, guys? Non-contact forces given by something called Coulomb's inverse square law. You will learn it. Anyways, so this is the background. So we talked about contact forces, non-contact forces. What else? Can force arise out of anything else? Connection of one body with another body. Connection of one body with another body. Suppose there is a box. There is another box which is touching that. Correct? In a way, that is also going to come under contact force. I'll tell you one more. What about pulley? The force that is arising because of one body connected to another body through a string. Is that clear? So that is the third type of force. Okay. So with that little background, right, we will enter into the topic. Okay, we are going to go step by step, and wherever there will be doubt, you can interrupt me. I may choose somebody and ask questions. So you will need to answer, all right? Which means you need to be attentive. Okay, as already established by the teachers and principal. Obviously, discipline number one. Yeah, we'll be very free with you. As far as interaction is concerned, anything academic is concerned, we'll be very free with you. In case there is any indiscipline, then I know, as madam had already mentioned to you, you may not be permitted for the rest of the classes. That's very clear and loud to you guys, number one. But otherwise, you can be very free. You can interact with freedom. I don't want to be like, talking to walls, right? You must be interactive. That is very, very important, and alert, because I'll be asking questions. I won't simply ask question, who can answer? No. I will just point, get up, ask the question. Is that clear, guys? So you'll need to be fully attentive to the session. Okay, great. If you don't answer or the answer is wrong, that's fine. That's okay. But then, you should at least, you will realize, right, where you are. So let's move on, guys. If you listen, one thing is, if you listen properly, you can answer. That's it. Now we will be into the chapter. Please don't, just because lights are switched off, don't think it is movie theater, okay? Fine, guys. So what is Newton's, how many laws are there? 3 laws. First law, second law, and third law. What is Newton's first law otherwise called? Law of inertia, right? So what does it say? Yes. So if a body is already at rest, for it to start moving, you need to apply an external agency called force. If a body is already moving with uniform velocity, what is uniform velocity? Quick. What is uniform velocity? Uniform velocity. That's all. Velocity does not change. Uniform velocity does not change. If a body is moving with uniform velocity, then unless a force is applied, external force is applied, the body cannot be stopped. Probably you will not realize it. Okay, here, yes. Okay, students, right? So if a body which is moving with uniform motion means velocity does not change. Then in order to stop that body, I need to apply an external agency called force. Otherwise, the body will not stop. But in our daily lives, we don't realize that, right? Suppose you make a ball, you make it to roll on the floor. Does it stop after some distance or not? You think I have not applied any external force, but has there been any external force? Yes, friction. Friction has acted. Had there been no friction, the body would have started. I mean, it would go on forever. Right? Okay, great. Fine, guys. So now that's what is just in the first few slides. It's going to be dealt with. Okay, we'll quickly move on through that. Right? So if a ball is at rest, if I have to get it into motion, what do I need to do? It has to be kicked, or it has to be an external force needs to be applied, right? Suppose if I have to throw a ball upwards, what direction should I give? Upward direction. Obviously, upward push is required. So when there is a breeze, what is going to happen, guys? Tree moves, which is otherwise at rest. Okay. Okay, guys. Fine. So body which is in motion, if you want to bring it to rest, external force needs to be applied. Is that clear, guys? No, I'm applying my brakes from inside the car. But where is the impact happening? Why is it stopping? Because of the friction that is going to be between your tires and road. Clear or not? That's the reason it is stopping. Is it not something which is happening outside? Okay. An external force is needed to retard a motion or stop a motion. Retard means what? Slow it down, absolutely. Negative acceleration, you can call it. So a car is moving. If it has to be stopped, you have to apply retarding force. Is that clear? Okay, so the external agency of force is in contact with objects. In all these examples, what we have seen. So these are all what we have seen so far are all what? Contact forces. Clear? So there is a contact, you apply force on an object and there is going to be motion. There is a possible motion. But you can also have what? Non-contact force. For example, magnetic forces, non-contact force. A magnet can attract a magnetic material from a distance, isn't it? A ferromagnetic substance. It's clear that external agencies can also exert force on a body even from a distance. So what is basically a force? How do you define a force? Force is basically, I think you have learned it from 9th standard. Am I right? Force is basically a push or a pull which generates or tends to generate motion in a body which is already at rest, or stops or tends to stop a body in motion, or tends to change the shape of the body. Okay, guys? Now, listen here. What are these 3 points? What is force basically? A push or a pull. And 3 things. A body which is already at rest. With that force, what you can do? You can make it move. Or you may not make it move. It tends to move. I hope you understand, right? Suppose I want to push this. Maybe I'm able to push the notebook here, but I'm not able to push this. I'm still putting effort, correct or not? The force is there. This object is tending to move, but it's not moving because the force is not sufficient enough. Force is not sufficient. Any idea what is opposing my trying to move this way? Mass indirectly, correct. Yes? Friction directly. Friction directly. Friction is related to mass. Greater the mass, greater will be the friction also. Okay, we are going to talk about that. Fine, guys. So a body which is at rest, if I apply a force, then it may start moving. It may not also, right? But it tends to move. Or if a body is moving, I may be able to stop it with a force, or I may tend to stop that body. Correct or not? For example, your friend is running towards you, you want to stop him or her, probably you'll apply some force and make him or her stop. Correct? Suppose Shatabdi Express is coming, you're on the track. Hopefully no. Your intention is okay to stop the train, but you may not be successful in it. Correct? So tend to stop. Okay? You know, this is very clear, right? Question 2. Okay, guys. Now the other thing which was talking about is, tends to change the shape of the body. Probably, right? Suppose you have a box which is already at rest. You take a hammer, hit on that. You are not making a body which is at rest to move. You are not making a body which is moving to come to rest, but you are trying to change the shape of the body. Is that clear? You are either changing the shape or tending to change the shape. Correct? That's the third point. Okay, guys. Okay, what is an internal force? Yeah, any doubts at this point? Okay, what is an internal force, students? What is internal force? You talk about a system, external force you understand, right? From outside you apply a force. What is internal force? Sorry? Yes, you are applying that force from inside. Is that clear? For example, let's say we are going to discuss that example. Let's say there is a car. Now let's say you're trying to, let's say the car is moving, okay? You're applying some force on the doors and other places and trying to stop the car from inside. Applying the brake is a different mechanism, right? Although also you're applying, something is happening outside, right? It's external force which is making it stop. Correct? But internally you're trying to, push the car. Does it work? Does it work? No, right? So internal force is going to be forces that are acting inside the system under consideration. Correct? For example, two people are sitting inside the car. Is there gravitational force between the two people? Yes or no? Do you think gravity is only for you onto the earth? No, right? Any two objects which are there will have what? Newton's gravitational force. I think lower class you have learned gravitation chapter, correct? F is equal to G m1 m2 by r square. Correct? So every body in the universe exerts a force on every other body. That's called what? Newton's law of gravitation. Correct or not? Okay, guys. So let's say there are four people sitting in the car. There are forces acting inside, yes or no? Maybe inside the person there are atom molecules. They are having forces. Correct or not? Those are all what forces, guys? Internal forces. They cannot bring about a change in the motion of the body. Is that very clear to you? So if the force applying agent is inside the system, then it's known as internal force. It does not provide motion to the system, which means it can do nothing to it. It cannot change the velocity of the moving body, or it cannot, make a body which is at rest to move. Clear, not clear? Any doubts, please? If you're sitting in a car and you push it, it doesn't move. You come out of the car and apply the same force, it moves. Clear, guys? Okay. Let me ask somebody. Yes. Yes, your good name? Joel. So what is the force, Joel? Look at the options and tell me the answer. Which is the right answer? All of the above. Good, good, very good. You're good on the records. Good. Let's move on. Okay, now, next, Joel. What is an internal force? Here, what is the answer, guys? What is an internal force? Force applying agent, where is it? Inside the system. That's what we just discussed. Okay. Okay, guys. Now comes to inertia. Okay. What is inertia? What is inertia, students? You sleep, morning you have to get up, and you don't get up, right? You continue your sleeping until a mom comes inside and gives a hit. Yes or no? What is that? inertia. What is inertia? Tendency of a body to remain in a state of rest or in its uniform motion. Okay, start watching reels, Instagram reels. External force has to come inside and say, come on, it's time to study, keep it away. Correct or not? A body continues to remain in motion until an external agency called force acts on it, right? So earlier physicists used to call it laziness. Okay, guys? Anyways, we'll have all those aspects covered. Let's first learn about the first law of motion. It's also called as law of inertia. To understand Newton's first law, we need to learn about inertia at first. What is inertia, guys? Okay. If the net external force is zero, if there is, the body is in equilibrium. What is under equilibrium? Net external force is zero. That means what is zero? Tell me something else which is zero. Yes. Acceleration is zero. Give a good round of applause. When net external force is zero, acceleration is zero. If acceleration is zero, what can you say about something else? Velocity will be constant. Fantastic. Give yourself a good round of applause. Very good. Listen now. So when external force is zero, acceleration is zero, which means the velocity of the body does not change. The body is either in uniform motion or it is at rest. Clear? That's when we talk about inertia. Okay. So either the body is at rest or what? Body is in uniform motion when the external force is zero. So when the body is at rest, it continues to remain at rest. Yes or no? If a body is in uniform motion, then it continues to remain in uniform motion. Is that clear? What velocity does it move with? Uniform velocity. Uniform velocity means what? Constant velocity. Why is the velocity constant? Acceleration is zero. Why is the acceleration zero? Because the external force is zero. This property of the body is called what? Which property? When external force, net external force is zero, the tendency of the body to remain at rest if it was originally at rest, or if it was initially traveling with a particular velocity, to remain in that velocity, this tendency of the body is called what? Inertia. Yeah? Any doubts? Okay, we'll move on. So what is inertia, guys? Resistance to change. Correct? A ball will stay at rest unless acted upon by a force. Happens or not? At home, you eat food, plate is at rest after you eat the food until mother comes and tells you, right? Come on, put the plate in your sink, correct? Happens or not? Okay. So now, coming to the point. Inertia depends on what, guys? Mass. Greater the mass, greater the inertia. Lesser the mass, lesser the inertia. For example, which is easier, guys? Let's say there is a cat sleeping. You want to set it up into motion. What do? Just a tap will do, correct or not? You're giving a force, you start moving. Now elephant is sleeping. Okay? A tap won't do, right? Is that clear, guys? It may not set it up into motion. So a body which is at rest, if you want to make it move, right? You'll have to apply a force. If the body has greater mass, greater is the inertia. For example, I can move this book very easily, but this entire table is difficult for me to move. You understand my point? Inertia of the table is more than that of the book, simply because of the mass directly. Of course, what is opposing it? Yes, friction. Okay. We'll come to that. Similarly, a body which is already moving, for you to make it stop, right? Again, it depends on what? Inertia. Greater the mass, greater the inertia. I gave this example earlier. Your friend is running towards you at 20 km per hour. You want to stop him, you will apply a force and you will be able to stop him, probably, right? Now, Shatabdi Express is running towards you 20 km per hour. You better stay away from the track, correct? You understand what I'm saying? You may not be applying the same force and expect the Shatabdi to stop. Correct or not? Yes. Because inertia depends on what, guys? Mass in linear motion. All this what I've told right now is applicable for what motion? Motion in a straight line or inertia, no? Linear motion. When it comes to rotational motion, the dynamics are different. Okay, we'll discuss that later. The chance is there. You understand this, right? It is stable. You apply a force and you are going to set it up in motion. Okay, guys, now he's trying to move the sofa. He's not able to move it. Let's say he tries a few more times, he cannot move. It's larger in size. Let's say it is also heavier. Still it is stable. Is that clear, guys? So things like to stay the way they are, right? Unless teacher tells you, right? Come on, study, get high score, have a good aim, go higher. Probably we may tend to stay where we are. It's not willing to move. Yeah? What do you call such things? Lazy? Okay. This is how physics also used to say. All things in the universe are generally lazy. Some external forces required, right? I usually say there are no lazy people. There are only people who are yet to be inspired. Some are inspired, they are like fire, okay? Some are uninspired, or other people, they look like lazy people. Okay, no object in this world starts moving on its own without an external push. At the same time, a body which is moving in uniform motion does not come to rest without an external force. Okay? Okay, if things are lazy, they don't want to move, how does movement happen? Come on. Okay, now the ball is small, he's able to move it. So even for a small thing to move, we may have to take more efforts, correct? Some students, even for them to score a pass mark, the teacher has to put in a lot of effort sometimes. Yes. Okay, guys, push and pull are things which make the objects move and change their positions. If you want to change the position of an object, you want to change the position of an object from wherever it is, you need an external agency called force, unless it is having uniform velocity already. If the force is not acting on the ball will not stop. Suppose if it started moving, it will never stop if the force is not going to act and make it stop. No, sir, I kick the ball in the ground. After some distance, it stops. External force is acting, friction is acting. In atmosphere, it stops because of what? Suppose you throw a ball up. If there is no gravity, if there is no air friction, what will happen? Keep going, it will keep going. Okay, air resistance. Air resistance is the one because of which in air, when a body is in air, there is friction, guys. I spoke about only two frictions, right? What frictions? Usually we are associating it with what? One object which is on another surface, correct or not? But air also offers friction, right? That is the only reason, okay? You have, let's say, an iron ball and you have a feather, bird's feather. Would you believe this? If I keep them at the same height, drop a iron ball and a feather, which will come reach the ground fast. Iron ball, right? That's your experience, correct? Anything else I say, you wouldn't believe, correct? If I perform the same experiment in vacuum, no air, all air sucked out, and I'm dropping a ball, I'm dropping a feather, what do you expect? Both will fall at the same time on the earth surface. Okay, guys? So it is air friction because of which your feather is taking a whole lot of time. If there is no air resistance or roughness on the ground, any obstacle, no obstacle is there, then the ball will keep moving and it will never stop. Okay, guys. Okay, physicists have a special name for this, what may call as laziness, right? inertia. Okay, write the appropriate definition given in the text. This is for your understanding. Don't write. Define inertia. Laziness. Get out. Okay. So write what is given in your text for writing the definition. This is for your understanding. Okay. If things are at rest, they want to be at rest. If things are in motion, they want to continue being in uniform motion. This is Newton's first law, guys. What is its state? Now look into it. Every body continues to remain in a state of rest or in a state of uniform motion until and unless an external force is applied. Okay, who else shall I ask now? Yes. Sure. Yes, sure. Tell me. What is inertia? Come on, tell me. It is the property of the body to oppose change in a state of rest or motion and vice versa. Second one, it is the property of the body to change from rest. Third one, it is the property of the body to change from motion. None of the above. Which appropriately defines it? What is the answer? E. It's the property of the body to change from rest. What did we say, ma? It's not only about a body which is at rest to change to motion, but also a body which is in uniform motion to stop. Sit down. Okay. Which of the following is also called law of inertia? First law of motion. Good. Why sir is asking such simple questions to me? Huh? Okay, guys. So we summarize. What is it? This is what you need to write in the exam, right? When you're asked. Every body continues to be in the state of uniform rest. In the state of rest or uniform motion in a straight, and all these words are important. Unless and until it is compelled by an external force. Or you can simply say unless and otherwise an external force is applied. This is a perfect apt definition. So what is Newton's first law of inertia? Every body continues to remain in its state of rest or uniform motion in a straight line until and unless there's an external force is applied or external agency called force is applied. This law is called law of inertia. Okay. Natural tendency of the objects to keep doing what they already are doing. All objects resist change either in a state of rest or uniform motion. Okay. Now, unbalanced force, guys. What do you mean by unbalanced force? Not balanced means what? It's not constant. Okay. Anybody else? What do you mean by a body is subjected to unbalanced force? Huh? Yes, somebody said not a balanced force. Then to them I am asking question, what is balanced force? Huh? Okay, guys, listen now. Listen. Very simple. It is the opposite scenario of equilibrium situation. What is equilibrium situation, students? All the forces, let's say in a body, there are 3-4 forces acting. All these forces cancel each other effectively. Then what is it called? Balanced forces are acting, you say. Net force is what? 0. The body is said to be in equilibrium. It will not change its velocity. If it is at rest, it will continue to remain at rest. If it is in motion, it will continue to remain in uniform motion. When what is applied? Balanced forces are applied. Very simple. Come with me. Here, listen now. Observe here. Stand. Okay, now. What kind of force I'm applying? Some force I'm applying and it is moving, right? Now you apply some force similarly. Just to try. Okay, he's applying some force, it's moving, correct or not? Now, I'm also applying force, you also apply force. We'll balance each other. Okay, now what is happening, guys? Now is the body moving? No. Let's say I'm applying 2 Newton, he is also applying 2 Newton. So what is the net force on this body? 0. The body is in what? Equilibrium or rest. Okay, at this point. Equilibrium need not be rest always. Equilibrium means external force, net force is what? 0. Now, when I am not acting, you move it. Now, what is the meaning? Unbalanced force is acting. What is the meaning of unbalanced force? There is a force acting which is not compensated by any other force. Clear or not? It may be one or more forces. Clear, guys? Thank you. You have a good round of applause. Okay, guys. So, what is an unbalanced force? That which is not cancelled by any other force. Clear or not? Okay. Now, tell me, guys. Is it okay? This book is here. This book, I keep it on the table. What are the forces acting on this? Is there any force acting on this book? Gravitational force is acting, correct or not? And normal reaction is also acting, correct? That is why this fellow is what? Not moving now. He is in equilibrium. Because gravity is acting in downward direction. Normal reaction is acting in the upward direction. So here I don't see normal reaction acting. Okay, let's keep this book here and I leave my hand. What will happen? Why? When I keep the book, gravity is not there. Gravity is not there. Huh? It is there, but it is balanced, right? It is opposed by the force that the wood gives on the book. So normal reaction is there. It is balancing the weight of the book. Therefore, the book is in equilibrium. Balanced forces are acting. Whenever balanced forces are acting, the body will be either at rest or if it is moving, it will move with uniform motion. But whenever unbalanced force is acting, then what will happen? Come on. Acceleration will be there. When acceleration is there, what will be there? Change in velocity will be there, right? Good. I'm sorry. Okay, guys, what happened, guys, now? I'm sure some of you would have experienced, right? What happened? Okay, this guy was skating and there was a stone and it hit and he fell down. What happened now? As long as you are skating, right? Let's assume friction to be negligible. So he keeps on moving, correct? Suddenly there is a stone that he has not noticed. What has happened? In the other direction, there is an unbalanced force, correct? So immediately that body changes its velocity. That's all. What happened to the skater? The skater changed its state from motion to rest. And for this to happen, an unbalanced force in the form of stone was required. Okay. So 3 types of inertia. What are they? Inertia of rest, inertia of motion, inertia of direction. The inability of the body to change from the position of rest is called inertia of rest. What is inertia of motion? The inability of the body to change by itself whenever it's in uniform motion to change its velocity. Unless an external force acts on it, that's called inertia of motion. Similarly, inertia of direction. What happened in this case, guys? He was not able to change because of inertia of motion. The car stopped. He also had to be there intact, right? But what happened? His inability, right? Because of inertia that he jumps, correct or not? So if you understand, when we understand this, then we make the designs, right? So you wear a seat belt that will compensate for it, right? Inertia of direction. Inability of a body to change its direction on its own until and unless an external force acts on it. Indirectly, this is also inertia of motion because when it changes direction, can I say, Prasanna? Last, get up. A good name? Sanjay. Sanjay, what is inertia? Very good. Until and unless an external force is applied, the object cannot change its position. Good. Now, why did this person fall off when the car hit the wall? Because of what? External force was applied, which was trying to make car from motion to rest, but this guy unable to maintain because of his inertia of motion, he jumped. Good, good, very good. You could have it. Okay, Sanjay. Now, you understand, right? When there is a bus which is moving forward, suddenly there is a brake. What do? You move forward. Again, because of what? Inertia of motion. You are not able to change from motion to rest on your own. When a bus suddenly accelerates or a two-wheeler accelerates, the one behind falls down. Or at least, if you're in the bus, you go back, right? Why? Again, inertia, right? Of rest. Bus was at rest, now it started moving. Okay. Okay, you should wear a seat belt, guys. Why here? Who should be there then? Okay, so one more. At least roof must be there in the car. So that's another lesson for him. Okay, good. So you are thrown outwards when a car suddenly takes a turn. Yes or no? What force acts, guys? Centrifugal force. You are thrown away, right? So which law of Newton is involved in this? Okay, who can answer this now? Quick. I know this is a simple question. Yes? Tell me. Okay, sorry. Which law? Did you read the question? No, read it now. Yes, you're thrown outwards when your car suddenly takes a turn because of inertia, right? Inertia of motion or rest or inertia of direction? Direction in this case. Good. Okay, now we'll talk about momentum. What is momentum, guys? Something which defines about the total motion of a body. Right? I'm sure you have learned. Have you learned in lower classes regarding momentum? What is momentum? Mass times velocity. Okay. Motion of a body is primarily represented by two quantities in mechanics. What are they? Momentum and kinetic energy. I'm sure you know the expression for both of them. What is momentum, guys? Mass into velocity. Mass into velocity. What is kinetic energy? Half mv square. Yes, where mass is m and v is velocity. Now, my question to you is momentum a scalar or a vector? Vector quantity. Vector quantity is something which has what? Both direction and magnitude. And what about kinetic energy, guys? Kinetic energy is scalar quantity. Any energy, any work done is a scalar quantity. Clear? Okay, tell me the answer now. Kinetic energy is a scalar. It has only magnitude. There is no meaning to say kinetic energy is acting in north direction. Energy is what? Scalar. No direction for it. Only number, only magnitude. 5 joules of kinetic energy, 100 joules of kinetic energy. Only number, no direction. But when you talk about momentum, what? A body is traveling with, what is the unit of momentum? kg, meter per second. What is momentum, guys? Mass into velocity. Mass is measured in kg. Velocity is measured in meter per second. So it is kg meter per second. Now I say the momentum of the body is 5 kg meter per second. Not enough. I should tell in which direction. 5 kg per second, 5 kg meter per second along northeast, or making an angle of 30 degrees with north. The direction is important when it comes to quantities called as vectors. Can you give me examples for vectors quickly? Distance, vector or scalar? Big, scalar. Displacement, speed, velocity, momentum, force. Force. Not sure? Your friend is standing on the 5th floor. Top. You are in a hurry to save him, right? You are fearful. You are running towards him and applying a force of 10 Newton. What will happen to him? It depends on which direction you apply the force, guys. If you go and hit him like this, he will definitely fall. If you go and catch and pull him, what will happen? He'll be saved. Force is vector or scalar? Direction important. Okay, guys. Acceleration, vector or scalar? Vector. Okay, guys. Energy, vector, scalar. Work done, vector, scalar. Potential, electric potential. Lower class you have learned, potential difference. Scalar. Because potential is defined in terms of work done. Work done by charge, if you remember. Work done is scalar, charge is scalar. So potential will also be scalar. Anyways, you will learn. Okay. Guys, come on, tell me, guys. If two stones of different masses are dropped from the same height, which one will cause greater damage? Talk about the one which has more mass, because momentum will be greater. Greater the momentum, greater will be the damage. So the stone, larger stone with greater mass will have greater impact because it will create more force. They will hit the ground with same velocity. If two stones of same mass from different heights are dropped, come on, tell me. From different heights, I am dropping. Same stones, same mass of stones. Which one will cause greater impact? The one which is thrown from greater height. Why? Because that when it strikes the surface of Earth will have more velocity. Mass is same, but velocity is more for the one which is coming from the greater height. Therefore, momentum will be greater for MV. MV will be greater for a body which is thrown from a dropped from a greater height. Therefore, that will create more impact. The stone falling from greater height produces greater damage. Because stone falling from greater height will have larger velocity and hence it will apply greater force. Okay. If two stones of different masses are dropped from different heights, what will happen? Two stones are dropped from different heights. Then whichever has the larger mass, whichever is thrown from the larger height, you should calculate both. Greater the mass, greater the height from it is thrown or dropped, greater will be the impact. Basically, M into V, that's it. The stone of larger mass dropped from greater height. That combination gives maximum damage because MV is maximum for that. Okay, guys. What is momentum? How do you define momentum? Momentum of a body is defined as the quantity of motion contained in it, or in simple terms, it can be measured as what? Product of mass and velocity. This is denoted by P. If mass of the body is mv or velocity of the body is v, then what is momentum given by P is equal to mv. Right? And it is a what quantity, guys? Vector quantity. Yes. Okay, what are the units of momentum? Quickly. So you see that vector notation. Because momentum is a vector, velocity is a vector, mass is a scalar. Okay, what is the unit? Gram centimeter per second in CG system. In SI system of units, kg meter per second. Dimensional formula. What is the dimensional formula for momentum, guys? Kg, what is it? Capital M. For meter, what is it? L. For second, what is it? T. Second power minus 1, therefore it will be T power minus 1. M, L, T power minus 1. Kilogram is M. Meters is length, so L. Kg is mass, M is length, meter is length. Second refers to time, so time inverse. Obviously, momentum is a vector quantity whose direction is same as that of velocity. Momentum and velocity have same direction. Clear, students, so far? Any doubts? Now we are going to enter into Newton's second law of motion. So what does Newton's second law states? What does it state? Anybody? You will be learning it from 9th standard, I'm sure. At least tell me the formula which is given by Newton's second law. Yeah, force is equal to ma. Force is equal to mass into acceleration. Clear? F is equal to ma. But definition of Newton's second law is not that. What is definition of Newton's second law? Come on, anybody? Okay, let's move on. Shall we move on? Yes. Everybody stand up. Everybody stand up. Okay. Stretch yourself. Stretch yourself. Okay. Stretch yourself. Just stretch yourself the way you want. And sit down. Stretch yourself. And move your hand up. Let's break. All right, back in action. Okay. So what is Newton's second law, guys? Quick. Rate of change of linear momentum is directly proportional to the external force acting on it. All right. The rate of change of momentum of a body is directly proportional to the net external force acting on the body and takes place in the direction in which the force acts. So what should be present? Net external. What do you mean net external force? Unbalanced. Clear? There should be a net force which should be there, which should be external force. If that is there, then that external force will be directly proportional to the change in momentum. Or how can I put it mathematically? Force is directly proportional to what? Change in momentum. Change in momentum. What is it? If momentum I am representing by P, what is change in momentum? Delta P. With respect to what? Time. So F is directly proportional to, listen everybody. F is directly proportional to delta P divided by delta T. Change in momentum by change in time. That is called average force. Instantaneous force at a particular instant, force is given by what? dP by dt. dP by dt. What is dP by dt? rate of change of momentum with respect to time. So force, net external force is directly proportional to rate of change of momentum with respect to time. Rate of change of momentum of a body is directly proportional to the net external force acting on the body. And what is the direction? It takes place along the direction of the force, because momentum is a vector. Force is also a vector. Okay, according to the first law of motion, if no external force acts, then the body will continue to remain in uniform motion. So momentum will be what? 0. And so change in momentum will be 0. Velocity is constant. If no external force acts on the body, momentum remains constant. Okay. If you have learned a little bit of calculus, which is there in your first chapter, I mean motion in a straight line, you will appreciate this little more. Even otherwise, I'll tell you in both ways. Okay. What is force, guys? Force is equal to dP by dt. What is F? Force, external force, net external force. What is P? Momentum, rate of change of momentum with respect to time. If a body is moving with uniform velocity, listen now. What is the body moving with, guys? Uniform velocity, which means velocity is constant. If velocity is constant, what is constant? Velocity is constant. What is constant? Momentum is constant. Give a good one plot. Quick. M into V. Velocity is constant means momentum is also constant. Momentum is equal to mass into velocity. Is that clear, students? So if momentum is constant, correct? In calculus, you will learn. If you have already learned, you know this. Rate of change is nothing but differentiation. Differentiation of momentum with respect to time. dP by dt. What is differentiation of a constant, guys? Louder. Differentiation of a constant. Louder. 0. Exactly. If you differentiate a constant, you get 0. Now, if you see, when I say uniform velocity, velocity is constant. If velocity is constant, what is constant? What is constant, guys? Momentum is constant. If velocity is constant, momentum is constant. And what are we trying to do? Differentiate momentum. But what is momentum? Louder. What is momentum? Constant. What do you get when you differentiate constant? Louder. 0. So that is what is told by this statement. If no external force is acting, if the net external force is 0, then momentum is what? Constant. Momentum is constant. Or reverse. If momentum is constant, what is external force? Are you able to connect these two things? Okay, sir, I don't know calculus. I don't know head or tail of differentiation, what you're talking about. I don't know. Momentum is constant means differentiation of constant is 0. I don't know. Don't worry. I'll tell you another way. What is force? Average force. What is average force, guys? Change in momentum by change in time. If a body is, listen, fully attentive, Come on. If a body is traveling with uniform velocity, what is its momentum? Constant. If its momentum is constant, what is the change in momentum? Momentum is constant, not changing. Then what is the change? 0. That means delta P is what? 0. If delta P is 0, what is delta P? What is delta P? Change in momentum. Change in momentum is, why is it 0? Because velocity is constant, velocity is not changing, so momentum is not changing. Therefore, delta P is 0. If numerator is 0, what will happen to the entire value? So force is 0. Are you able to relate now? Even without understanding calculus, you can do this. So you can connect it both ways. If external force, net external force is 0, momentum is constant. Or reverse. If momentum is constant, external force acting is. That's what we were trying to tell you. Okay, so mathematically, what is F? F is directly proportional to what? dB by dt. Hence, when the momentum of a body changes, body must be under the action of a external force, which means if there is no external force, no change in momentum, momentum will be constant. If momentum is changing, that definitely means what is there? External force is there. Why is momentum changing? Because velocity is changing. Why is velocity changing? Because there is acceleration. Why is acceleration there? Because there is a force. I repeat once again, and we'll move on. When external force is 0, dash is constant. Momentum is constant. When momentum is constant, what is the net external force? 0. If momentum is changing, that means what is changing? Velocity is changing. If velocity is changing, what must be there? If acceleration had to be there, what should have been there? External force. Net external force must be there. So that's what we are saying. Whenever momentum changes, a net external force is required to be there. Is that clear? Okay, we'll move on. We'll ask somebody a question now. Go ahead. What is momentum? Very good. You have a round of applause. Product of mass and velocity. Have a seat. Okay, if two stones of same mass from different heights fall on a vehicle, which one of them causes greater damage? Stone from a greater height. Yes, why? Because velocity will be more when it hits it. Very good. Give a round of applause. Okay. Option C. Very good. Give a round of applause. What is momentum? Mass into velocity. Mass is measured in kilogram. Velocity is measured in meter per second. Kilogram, what is the dimension? Capital M. Meter per second, what is the dimension? Meter length L. Second T, power minus 1. So MLT power minus 1. Very good. Okay. So now we define second law of motion. The rate of change of momentum of a body is directly proportional to the applied force, and it takes place in the direction of the force. Rate of change of momentum is directly proportional to the force, and it will be acting along the direction of the force. Second law of motion relates to the net external force and the acceleration of a body. Already we know the answer. We are just getting to that. What is our answer? We know F is equal to M into A. Force is equal to mass into acceleration. Okay. Okay. See here, I am applying some force on this. Okay. Let's take something which I can do. Can you bring the chair? Guys, who can answer this question? What is your name? Who asked the question? Okay. Okay, guys, now listen. Oh. Have we moved forward or backward? I don't know. Right? Okay, good. Okay, guys, now. Okay. Listen now, listen. Okay, now I am applying a force of, let's say I'm applying a force of 2 Newton. Okay, now you come. You apply a force. Let's say he's applying some 1 Newton, 2 Newton, 3 Newton, doesn't matter. Okay, now the body is moving. Now what is happening is I am applying 2 Newton from this side. You also apply some force. Let's say it is at equilibrium now. What is the meaning? We both are applying equal force. What is the net external force? 0. Now, I am applying 2 Newton. You push it little harder. Okay. I am also applying the force, but he is applying greater force. So I am applying 2 Newton. He is applying 5 Newton. So what is the net external force now? Understood now? 3. You go to the papers. Because we may not focus, right? One word, net. How does it matter? Should I ask, sir? But he asked, we didn't think about it. Good. Okay. Now, next. Acceleration is produced when a force acts on a mass. Greater the mass of the object, greater is going to be the force that is required to accelerate the object to the same extent. Clear or not? Simple. I want to move this book and bring about an acceleration of 1 meter per second square on this. Then I need to apply some force. But if I want to move this and make it move with the same acceleration 1 meter per second square, force required is same, less, greater. Greater, that's what it says. More mass, more force is required to bring about same acceleration. This we know, right? If you want to move a heavier object, what force you have to apply? Yeah. So all of us are experts in Newton's second law, correct? So it gives exact relationship between force, mass, and acceleration. So it talks about how fast an object can move for a particular force and a given mass. So mathematically, second law can be given by what? F is equal to ma. Mass into acceleration. And Newton's second law, among all 3 laws, is considered to be the most significant law. Second law measures the quantity of force, whereas first law of motion describes the concept of force. What does first law do? Describe the concept of force. An external agency called force, unless it acts, the body will not move from rest, or it will not come to rest if it's undergoing uniform motion. Correct? That's what it says. It introduces the concept of force for you guys. First law. Second law quantifies how much F is equal to ma. So what are the units of force, guys? Come on, tell me. Newton in what? MKS system, or you can say SI system. MKS means what? Meter, kilogram, second. What is CGS system? Centimeter, gram, second. So there it is called as gram, centimeter per second square. Or it is also called as what? Dyne. Here kilogram, meter per second square. Because it is very easy to understand. Correct? What is force? Momentum by time. Momentum, what is the unit? Kilogram, meter per second, divided by second. So what is it? Kilogram, meter per second square, or ml, t power minus 2. We'll see that. This is important. 1 Newton is equal to 10 to the power 5 dyne. So how do you define 1 Newton? We know the formula. F is equal to ma. If F is 1 Newton, m is 1 kg, and a is 1 meter per second square, then that force is called what? 1 Newton. So how do you define that? If a force produces an acceleration of 1 meter per second square on an object of mass 1 kg, then that force is called what? 1 Newton. Simple idea. F is equal to ma. If m is 1, a is 1, F is also 1. M is 1, A is 1, F is 1. So, a force which brings about an acceleration of 1 meter per second square on a 1 kg mass is called 1 Newton. It is a unit of force. Like Newton, what is Newton? Unit of force in SI system. CGS system, it is called time. It is also called as gram centimeter per second square. Dimensional formula I told you, mLT power minus 2. Minus 1 is for momentum. By time you do. Momentum by time is force. So one more time will come down. So it will be T power minus 2, not T power minus 1. Okay, guys, now tell me this answer. Who is going to tell me this answer? Yes, I'll find out somebody. Yes, come on, Fusail, get up. Ramu's car, which weighs how much? 1000 kg is out of gas. It's a 9th standard question, guys, not 11th. Okay, you can definitely answer. Ramu is trying to push the car to the gas station. He makes the car to move with an acceleration of 0.05 meter per second square. How much force he must have given? Tell me. Into 1000. Give a good round of applause. F is equal to MA. That's 1000 into 0.05, which is 50 Newton he must have given. Then he would have produced that acceleration. Direct formula F is equal to MA. Now let's look at MCQs now. Yes, ma'am. Your good name? Emmanuel. Tell me, Emmanuel. Second law of motion. Yeah, give a good round of applause. The most significant law is, among them is second law, right? Silent. Now I'll ask somebody. Yes, Roshi, tell me. 1 Newton. Give a good round of applause. A force which brings 1 meter per second square for a mass of 1 kg. That's the definition of 1 Newton. Okay, this is very, very important. Derivation of Newton's second law of motion. Extremely important question. So what is the statement, guys? Rate of change of momentum of a body is directly proportional to applied external force, and it takes place in the direction of the force. So what is the formula? F is equal to dp by dt. I will just write it and show you, then I will show it on the PPT. Okay, so now tell me, wow, how force and momentum are connected. F is equal to dp by change in momentum by and rate of change of momentum. So what is F equal to? dp by dt. What is P? Momentum. What is momentum? Mass into velocity. So what can I write? Momentum as mass into velocity. Which of the two is constant? Mass is constant. I can take it out of the differentiation. So what is force going to be equal to, students? dp by dt. And what is P? What is momentum? Mass into velocity. And which of the two is constant? Mass is constant. Take it out. So you'll get m into dv by dt What is dv by dt? Rate of change of velocity with respect to time. Acceleration. And there you go. Clear, guys? So F is dp by dt and momentum is nothing but mass into velocity. Mass is a constant, so you can take it out of the differentiation operation. So it will be mass into dv by dt. dv by dt is rate of change of velocity with respect to time. That is called acceleration. All these concepts from first chapter. Motion in a straight line. So what is rate of change of displacement? Rate of change of displacement with respect to time. What is ds by dt? ds by dt, velocity. dv by dt, acceleration. So we get dv by dt here. That is nothing but acceleration. So this is the expression connecting your force and acceleration. Newton's second law. Because force is a vector, you can denote vector notation. Mass is a scalar, you can take it out. On V, you can have a vector notation because V represents what? Velocity. A mass is not a vector, it's a scalar, so you don't put any arrow on that. Mass comes out. What is acceleration, guys? Vector, so I should have a arrow representation. So you prove that force is equal to m into a. Sir, I don't know. I don't know differentiation. Whatever you write, dp by dt, all I don't understand. Okay, then there is something else for you. We'll hold this for a minute or two. It's okay. Shall I move? Okay, just right. Students, you'll be having a break not at 11 o'clock. You'll have it 3 minutes earlier. Okay. So 10:45 you should be having a break. Okay, 10:45 to 11. 11 we are commencing the next session. All right. 10:45 will be stopping, and I will see that I'll see that. Do they open the restrooms only when break is there? Or it's all open, right? Okay. So then 10:45 to 11, you're moving out, and then you're completing and coming back sharp at 11. So that my intention was, you don't need to go along with everybody. You can go early, come back fast. Done, Kiran? Okay, let us say you did not know. Sir, I don't understand differentiation. I don't know the basics of that. Then I will tell you one more way of doing it. That's also accepted in PU. Okay. Chalta hai. Fine. What is force? Rate of change of momentum with respect to time. You should only write it as dp by dt. That is the actual thing. Rate of change of means d by dt only. But some concession for those who do not know differentiation. What you can do? Instead of finding instantaneous force, we'll find average force. It's okay. What is average force? Change in momentum by change in time. Listen, everybody. What is average force? Change in momentum by change in time. Delta represents change. Delta represents change. What is change, man? Final minus initial. Final momentum, come on, final momentum minus initial momentum divided by change in time. Okay. Now, what is final momentum? What is final momentum? Mass into final velocity. What is initial momentum? Mass into initial velocity. is m into v minus q by, you can maintain it as delta t. What is v minus u? Change in velocity. So change in velocity by change in time. What is it? Average acceleration. Another way of doing it. That's all. Understood? I repeat this. First page. Okay. What is force? Force is nothing but change in momentum by change in time. What force are we finding? Average force. In earlier case, instantaneous force. Force at that instant, dp by dt. Rate of change of momentum with respect to time. Okay, anyways. Okay. So final momentum minus initial momentum. Final momentum is what? Mass into final velocity. Initial momentum is mass into initial velocity. Change in time is delta t. So mv minus mu. If you take m outside, you'll get what? V minus u. V minus u is what? Change in velocity. Change in velocity by time is what? Acceleration. That is F is equal to ma. You can also do this way. It is okay. Have you all noted down? Yes, no? Yeah. Rate of change of momentum is directly proportional to the applied external force and it takes place in the direction of the force. Okay, now, if under the action of the external force F for a time interval dt, the mass of the body remains same, but velocity changes from what it was v to v plus dv. So what is the change, guys? Final value minus initial value. So what is the change in velocity? dv. Initially v, now what? v plus dv. So what is the change? v plus dv minus v. So v cancels. What do you get? dv. Initial momentum v vector is equal to m into v, changes by dp. dp is nothing but p, you can write it as m into v. So m comes outside dv. According to Newton's law, rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction of the force. So F is directly proportional to dp by dt. Proportionality constant k. Clear, guys? And P I can write it as m into v. M is a constant, take it out. So m into dv by dt. So F is equal to k into m into dv by dt is nothing but acceleration. Okay. Now, k is a constant in SI, its value is going to be 1. Therefore, F becomes equal to ma. That's it. Same thing. Okay. What does dv represent? Small change in velocity. The ideal word for that is, in your text, if you see, infinitesimal change. Very small change, sorry. Infinitesimal change. dv. Suppose if I say dx means very small change in x. Infinitesimal change is called dx or dv. Just give me a minute if in case you want to note down. Already multiple variations I have given you. You can write any one of them. What do you want to explain? Give the definition. What you should explain in this definition of force. Force is directly proportional to rate of change of momentum, dp by dt. Then momentum is nothing but mass into velocity, mv. Then mass is constant, you're taking it out. dv by dt is acceleration. All this you should write. Not only this. Okay. Okay, now next. Let's move on. Units of force we already saw. What is it? Newton or dyne. And you know the relationship also. Dimensional formula, you know, ml power minus 2. For momentum, what is the dimensional formula? ml power minus 1. Sometimes, because you know, most of the time, when we are dealing with force, right? Many times we'll be talking about gravitational force. That's the reason, you know, we say in terms of kilogram weight. For example, you go and you go and ask in a store, right? Give me 5 kg of rice, right? What are you buying? Are you buying 5 kg mass of rice? No. You are buying 5 kilogram weight of rice, which means 5 Newton of rice you are buying, not 5 kg of rice. Probably you are only buying 0.5 kg of rice. Mass is 0.5 kg, but weight is what? 5 Newton. But you keep saying to the shopkeeper, 5 kg rice. But actual meaning is what? If you are a physics person, you should say, give me 5 Newton of rice. Okay, don't do that. Fine. 5 kilogram weight, you can ask. In a sense, you know, actually another way of saying 5 Newton is what? 5 kilogram weight, which means what? With 5 is the mass, you are multiplying g. What is g? Acceleration due to gravity, which is 10 meter per second square. So that, you get my point. 5 is equal to mass into g. Already g is included. So what is the mass actually? 0.5. Okay, guys. Anyways, now listen now. 1 kilogram weight is nothing but what? G into N. What is G? 9.8. If you are talking about 1 gram weight, what is it? 989. Okay, now. This boy. Yes, your good name? Satish, tell me, Satish. What is the relationship between force and acceleration? Directly proportional. Give a round of applause. Yes, Kelvin. What is the SI unit of force? Newton. Give a round of applause. Okay. Now we look at applications of Newton's second law. Okay, we understand if u and v are the final velocity, initial and final velocities, almost. U and v are the initial and final velocities of the particle of mass m, and average force acting on a particle at a time dt is given by what? F is equal to dp by dt, or change in momentum by change in time, mv minus mu by dt. Or in other words, what is it? This we have already seen, correct? Okay, now look into this carefully. Now going forward, after the break, we'll go to the next level. So far, what we have done is, it's like, bridging you from 9th to 11th we have done. Of course, all these concepts are in 11th, but still we are not gone to that level. Is that clear? Still we are just playing around with simple stuff. Is that clear? Now, little more complex stuff we are going to see now. Okay? Clear? Or little more understanding is required, little more focus is required, little more interaction is required. Correct? That's what we'll do after the break. But starting with this, okay? There another 2-3 minutes or almost time. Okay, we'll just finish this. And the next one, I'll keep it open. Think about it, okay? And when we come back from the break, we will discuss that. Okay, now the ball of mass m strikes. So from now, we're going to second gear. Okay, so far we were in first gear. If a ball of mass m strikes the rigid floor normally means what? Normally means normally, not that normal. Perpendicular, yes. So when I say normal, it means what? Perpendicular to the surface. Normal reaction. What is the meaning? A reaction force in a direction which is right angles to the surface. So normally means at right angles. Okay. Now, and rebounds with the same speed. So it strikes with some speed, and with the same speed, it's coming in the upward direction. Now, you might have seen in first chapter motion in a straight line. What did you see? Already the break is given. Did you reach the break now? Oh, then I'm sorry, guys. Then let's. Is it a good number? Good number of students have a break right now. I wanted you guys to be shielded from other PU students, but now it's like it's okay. You will go now. I'll just finish this and you go and come back fast. Here, in first chapter, you might have learned motion is straight line. When a body is coming down, right? Its velocity vector is in which direction? Downward direction means what do you take the sign as? Negative. It's minus mv when it's coming down. What is mv? Not velocity. What is mv? Momentum. So momentum is negative when it's coming down. It hits the surface and rebounds in the opposite direction. When it's coming in the opposite direction, the velocity is v. Is it plus v or minus v? Plus v because it's coming up. Momentum is plus mv or minus mv? Plus mv. When it goes down, it is minus mv. When it comes up, it's plus mv. Final momentum mv. Initial momentum minus mv. Okay. Can you tell me? Change in momentum? What is the change in momentum going to be? (2mv). Final momentum is mv minus initial momentum. What is initial momentum? Minus mv. So mv minus of minus mv will become mv plus mv. So it will become 2mv. So if t is the time of contact of the ball with the floor, then the force is given by 2mv divided by t. Change in momentum is 2mv. Time is what? T. It's 2mv by t. Clear to you? I leave it with this. Okay. Now what's going to happen? The ball is going to come and strike the surface of the wall, and it's going to rebound like this. Okay. Now in this case, what will be the change in momentum? I want you guys to tell me. Okay. Are you all ready, guys? Fine. So with this question in your mind, I give a break at this point, and exactly by 11 you are here. Okay, please move. It's okay. It's okay. Go. Nothing. No.